Hi, welcome to Train Signal. We're moving forward into a discussion of failover clustering, and specifically in this lesson we're going to turn our attention to the storage that underlies failover clustering. Failover clusters are an availability technique. If I want to be able to improve the fault tolerance, the high availability of some service, but I don't necessarily need scalability, my goal is to turn to something called failover clusters. Failover clusters allow me to group together a collection of servers in such a way that those servers back each other up. I can run a number of different applications on top of that cluster of servers, but for any one of those features, only one particular computer in that collection is ever responsible for performing the actions associated with that particular feature. In that sense, it acts a little bit like a normal server. If the situation occurs that that application fails or some harm comes to it, failover clustering works in such a way that we can fail over from the damaged server and pick up where we left off with that application running on one of the other servers in the cluster. This could be as small as just a couple of servers. It could be as many as 64 of them. So it could be potentially a very large configuration if need be. Our goal, again, is high availability. It's fault tolerance. Importantly, it's not scalability. In other words, we're not increasing the number of requests that can be handled by adding more servers. Instead, we're just increasing the number of other locations that this one application running on one particular server in the cluster can fail to in the event of problems. The goal there is to make sure that we're able to keep that feature up and running nearly all the time in such a way that a failure will be followed so quickly by the bringing up of that same application, that same service on some other server, that users connecting in will notice minimal downtime. So how do we make it work? The failover cluster component of Windows Server 2012 is a feature, so we'll go visit our Server Manager tool to begin enabling it. As we do so, we'll start by validating that the hardware that we have available to us is acceptable to failover clustering, and then we'll go tell the built-in failover clustering wizard to go ahead and create a cluster environment using the servers that we make available for that collection. For this environment, we're going to target servers 2 and 3 for that purpose, and we'll illustrate using those servers. So let me jump over to server 2, and we'll get this process started. So here on server 2, I'm going to go install the failover cluster software. Now I'm cheating a little bit by not going ahead and configuring storage first. I want to kind of illustrate the lack of ability to get much of anywhere with failover clustering without good configured shared storage between the servers. But just for illustration purposes, let's imagine that I didn't know that we're heading into danger here. Let me go add the failover cluster feature to this server. You'll note that it's not a role. It is in fact a feature. Features are things that support the use of a role. The role is in fact, in most cases, what we're going to be clustering with, our failover cluster feature. So installing it is pretty straightforward. Let me do the same thing over on server 3. So that'll start the process of getting the failover cluster software installed on servers 2 and 3. While it does, let me jump back to my slides for a moment because I want to address a couple of important points about the idea of failover clustering. In general, of course, we expect that a failover cluster's servers will all be relatively nearby each other. We'll tend to have a server room with a rack of servers, and 2, 3, a dozen of the servers in that rack will all be part of the same cluster. Failover clusters are characterized by the presence of shared storage, what allows us to be able to fail over a running piece of software from one server to another in a relatively short period of time is the important fact that those servers share storage. When the application on one of those servers is doing work, it's writing it not to proprietary storage on that physical box that could potentially be lost if that server fails, but instead writes it to a shared storage area that other servers are able to connect to. That generally implies the idea of servers being physically nearby each other. We might use the shared SAS, the shared serial attached storage drive system, where the servers are physically connected to the drive device. Obviously, we can't separate the servers physically because the cable only reaches a certain length. Other options include things like fiber channel. Fibre Channel uses dedicated hardware adapters in the servers called host bus adapters, HBAs, to connect to dedicated Fibre Channel switches, to connect to Fibre Channel storage array disks elsewhere in the server room, or perhaps somewhere somewhat further away. So we get a little bit more reachability, a little bit more distance with support for Fibre Channel. We could use iSCSI. If you haven't learned about iSCSI, there's a lesson in this Windows Advanced Features course that might deserve your attention. I invite you to check that out. But however it works, we need someone to be able to get to shared storage. That needs to be available from each server. We'll show you how to configure that for a failover cluster here somewhat shortly. It's worth noting that it is possible to deploy a multi-site cluster. In a multi-site cluster, we get slightly different behavior. We can now, if we choose to, in Server 2012, have the same failover cluster span multiple physical locations. Now that does create a couple of important considerations. Obviously there's the networking consideration. Do I have a fast enough connection between these two very disparate locations to be able to get data from one side to the other quickly enough to be able to make this an effective failover cluster? I want to be able to allow a failure on one side to be able to result in a service being picked up by a server on the other side of the network if need be. The other important consideration, of course, is a storage consideration. We want to be able to ensure that we've got some sort of storage for our data here, but we've got a problem. We can't get shared storage to easily span that distance. So what we typically end up with is two different storage configuration environments. I've got a Fibre Channel SAN perhaps on both ends of that connection, and those are separate from each other. But that kind of bends the rules of our usual idea that a failover cluster has shared storage among all of its nodes. If these four servers in my PowerPoint slide here are all sharing that same cluster, we should expect that they've all got access to the same shared storage. Well, how does that work? Well, there are a number of techniques to be able to make that work, none of which are provided directly by Microsoft. What we would now need is some sort of data replication from one site to the other. I need to be able to have some way to be able to ship the information that I configure on one server across the network to the other servers on the other side of the network, over in that other site. There are technologies out there that will do that synchronously, where I write a change to my local server. We will also write an identical copy to the data storage in the other site. And only after we've confirmed that it was written to the other site do we check it as a valid write locally in our local site. We can do asynchronous replication, where we write our change locally and then we rely on some piece of software to carry that change, hopefully, over to the other site. We run a slightly greater risk of loss of data there in the event that the local server fails before it gets a chance to ship that data out to the other server. We've now lost the information about that particular change to our server environment. But long story short, it is possible in Server 2012 to build a multi-site cluster if that's a valuable thing to you. So let's jump back to the servers and see how they're doing. Server 2 seems to have successfully installed the failover cluster components. Let me check Server 3. And Server 3 is also fine. Now that we've done that, we can start the Failover Cluster Manager tool. I can do that on either server to start the process of building a cluster that incorporates these two servers. And there we are. There's the Failover Cluster Manager tool. At the moment, there's no cluster configured in it. If I look over here at the left, there's nothing underneath the Failover Cluster Manager node. What I can do is begin the process of creating a cluster. And the first logical thing to do to be able to make that happen is to do a validation process. I can ask the Failover Cluster Manager tool to look at some set of servers that I might like to be part of a cluster and ask the question, does it seem right or reasonable for those computers to join a cluster? Let me launch the validation wizard here. Okay. We're going to click Next to be able to move forward into the wizard. It wants to know the name of the servers that I would like to join into a cluster. So let's take New York City Server 2. And New York City Server 3. In each case, the Add button is able to add an item into my list of servers that I wanted to select. Clicking Next, it wants to know, do I want to run the tests associated with a typical configuration or to run particular tests of my own choosing? I'm going to run all of them, which is of course the recommended configuration. So we can see that it's preparing to test server 2 and server 3, and it has a whole battery of tests slated to run against this environment. This tool, incidentally, is also a fine way to be able to troubleshoot a failover cluster that has developed a problem of some sort. I can rerun this wizard at any point, even after I've successfully created the cluster, to ask questions wondering, okay, what now isn't running in a way that would be appropriate to support this cluster? It's worth pointing out here as the tests proceed that Microsoft deliberately has built the failover cluster wizard in such a way that you can elect to not run these various tests before you build the cluster. But if you build the cluster without the validation tests, you're signing off on the idea that Microsoft doesn't need to support your cluster. The cluster wizard does check to see that you've got hardware in place that is appropriate for running a failover cluster. So Microsoft has done a lot of homework here to make sure that if you do build a cluster and you follow their rules, that it'll be supportable, that there won't be problems down the road waiting for you that Microsoft won't be able to help you solve. We can note as this proceeds that some of our events are passing successfully. Others are running into some problems. There are some warnings associated with some of these tests. We'll see later that these are tests principally that relate to storage issues. I warned you that I had not pre-configured storage appropriate for perfectly supporting our cluster. The cluster is as such a little nervous about some of the things that it might be asked to do in light of the fact that it doesn't know what the storage is going to look like yet. It does say that my report does contain warnings that I should address. I have the option to create the cluster now using the nodes that I have validated. Let me view the report that was generated so we can see exactly what it was that it didn't like. As I do this, Internet Explorer is going to say, hey, do you want to stop to configure sophisticated features of IE? And of course I don't. I'm going to not bother to set up any of those things. With that, we can see that there are some network-related concerns. As it checked out the IP configuration, it successfully identified the network adapter cards on server 2 and server 3. The wizard has identified here that neither of my network adapter cards on my servers has a default gateway configured for it. In this case, I'm not going to be routing to anywhere, so there's no concern there. Real world, you almost surely do need a router address, a default gateway address, to get data to the other portions of your network. Scrolling down further, there are a couple of different concerns related to disks. It was unable to validate that the disks available were able to use certain kinds of storage functionality. Now that's again because I did not configure any disks to start with. I'll do that as a second step in here in a moment. So long story short, it's happy. It seems to think that there's no serious showstoppers. It was unable to perform certain tests that it would have liked to have tested, but assuming that everything there works out okay, the tool is prepared to let me build a cluster. So I will leave the check mark in place that says create the cluster now and click finish. The failover cluster wizard is now going to start the process of building a cluster. That cluster needs a name. This is a friendly description of the cluster as a whole. I'm going to call this failover cluster 1. It wants to know on which network I want to expose this cluster and which IP address I want to use to make it available. So I'm going to say this is going to be available at 10.18.38.225, for example. So that's a management interface for the cluster as a whole. Having done that, it invites me to add all eligible storage to the cluster. We'll find that there isn't any eligible storage, but just for illustration purposes, I'm going to go ahead and click Next. There we go. We've successfully created a cluster. Over here on the left, if I expand the failover cluster node, we'll see that node is characterized by a set of server nodes. Server 2 and server 3 are my two nodes within my failover cluster. What I'll do with those servers is run some piece of software on them. And in general, that will take the form of a role. I will want to add to my system one or more roles, one or more sets of resources to be clustered, where that set of resources represents a DHCP server perhaps, or a file server, perhaps a virtual machine. We might cluster a good old Windows server. At the moment, of course, it's complaining at me saying, hey, I don't see a Windows server on server 2 or server 3. It's right. I didn't put one there. So our next logical step is going to be to add some roles, add some features to cluster after we've gone ahead and made sure that we've got some place to store the information about those features. So our next important goal is to configure storage, really. We'll double back for the roles and other software components later, but our first question is, where are we going to store the data that these two servers are going to use together to get things done? If I look in the disks collection, I don't see any disks to configure. I do have an add disk tool over here on the right. If I click it, I get a complaint from the system that says, hey, I didn't see any suitable cluster disks. Now what's it referring to here? Remember that the way in which failover clusters work is through the use of shared storage. That might be Fibre Channel, it might be shared SAS, and it might be iSCSI. And iSCSI is a nice cheap solution. Saves me the trouble of going out and buying host bus adapters. So let me go ahead and deploy iSCSI, and we'll use that for the purposes of this exercise. To deploy iSCSI, I need an iSCSI target. I'll go build one on server 1. So here on server 1, in my file and storage services area, we're going to add an iSCSI target server. So there we go. That puts the iSCSI target server on server 1. Having done that, I can configure it from over here, file and storage services. I won't describe all the details of what we're doing here. That was covered in the iSCSI lessons associated with this class. Let me build a new iSCSI virtual disk for this purpose. Wants to know where I want to put it. We'll put it on drive C. Needs an iSCSI target to make that storage available. And then we can identify which iSCSI initiators will be coming in to connect to this target. I've got a fondness for using IQN values, so I'm going to do that. And I'll do the same thing for server 3. I'll leave off authentication for the purposes of this exercise. We're ready to create our storage. Real world, I might create some number of virtual disks and make each of them available. Next step is to be able to identify that storage from the places where I intend to use it, which is to say from server 2 and server 3. So let me jump over to server 2. In server 2, I want to be able to manage that storage. I'll do so from disk management. Disk management is a part of the computer management tool. At the moment we see disk 0 and CD-ROM 0. We don't see the other storage yet because I haven't told the local iSCSI service to connect to that location. Found the failover cluster disk. Note that that worked because I configured on the target server the IQN that's present here for this server. Having done that, disk management now shows the presence of a 20 gigabyte offline disk. I'm going to bring it online. I'm going to initialize it to tell my server that it sort of owns that disk. And I'll go configure the storage that lies in it. We're going to configure it as a single 20 gigabyte partition with driver letter E using the NTFS file system. Looks good. There we go. Let me go to server 3 and do the same thing. Here on server 3, I'm going to use my iSCSI initiator. And I'm going to go get connected to New York City server 1, which is where my data resides. Having done that, let's go confirm our configuration in computer management. You can see through the magic of iSCSI that a 20 gigabyte partition is visible on something called disk 1. From the perspective of this server, it's referred to as offline. Let me remedy that. Let me bring this disk online from the perspective of server 3. There we go. Server 2 and server 3 both believe they have access to a drive on disk 1, a 20 gigabyte NTFS formatted volume. Truth be told, that data doesn't reside on either server 2 or server 3, it resides in server 1. Having done that, I can configure that storage as being available to my cluster. Here's my failover cluster tool. I want to add a disk to my cluster, and it says, hey, how about this 20 gigabyte iSCSI disk that I see? There we go. So we now have a place to be able to store data. The cluster has storage. I can now, as I begin to roll out services, store information that's important to an application in the cluster in that storage disk area. That data, because it's accessible via my SAN technology, in this case iSCSI, means that any data written by either server is going to be available to the other one. We can see that this data appears here as what's referred to as available storage. An important consideration related to that storage is how we're going to be using it in the future. What we've done so far, creating a set of shared storage, is fine for many, many purposes. There are some situations for which the storage configuration, the way that I've left it, will be inadequate. And one of them is management of virtual machines. If I'm using my failover cluster to manage failover of virtual machine logic from one server to another, to be able to make that work properly has been a challenge in the past. To fix it, Microsoft rolled out with Server 2008 R2 something called CSV, Cluster Shared Volumes. What's neat about CSVs is it does allow two or more failover cluster nodes to share ownership over a LUN, a logical unit number, a particular chunk of SAN provisioned storage. Prior to CSV, there was no easy way to do that. Only one host ever owned a particular chunk of SAN storage space, which made it much more challenging to do things like virtual machine failover, and we'll address that at a later point. For the time being, it's worth pointing out that there are a number of scenarios in which it's valuable to enable that shared LUN management. And we can do so by simply adding the disk that we've made available in our failover cluster environment to CSV. So here I am back here on server 3. Server 3 has a disk configured for available storage. If I select it, you can see that I have an option over here to add it to cluster shared something, and you might well guess that the ... means volumes. Let me stretch this way a little bit. There we go. So I can take this storage and with a simple mouse click convert it into CSV, cluster shared volume type storage. There we go. I now have a CSV. If I decide that I made a mistake making that a CSV type volume, I can select it again and remove it from the cluster shared volumes collection. But realistically, I'll probably create many more disks of this sort and add them to the cluster shared volume collection. That has a variety of benefits for a number of different kinds of storage that I might choose to deploy. One interesting new benefit to CSVs that we didn't have even in Server 2008 R2 is support for an ability to do some different kinds of management of file server failover clustering. We have been able to do failover clustering of file servers in earlier releases. One challenge with that is that we haven't had the ability to create scalability with file servers. We could create additional redundancy. And again, that's one of the hallmarks of failover clustering. So I can have multiple servers. If one fails, another one takes over the job of the one that died. That's a great benefit. And I'm not going to knock the benefits of that high availability solution. But in some cases, having all of these servers, it would be kind of nice if that allowed us to support a greater quantity of incoming requests at the same time, managing that load across the collection of servers that provide access to that shared file storage. We haven't had a way to do it. CSVs in Server 2012 do enable that scenario, interestingly. Something called the Scale-Out File Server solution. So we've walked through how to configure disk storage to support a failover cluster. We've seen how to turn on failover clustering overall, validating that cluster to confirm that the hardware that we've deployed is adequate to the task of doing a failover cluster. We've configured that cluster and made shared storage available inside of it, optionally turning it on as cluster shared volume type storage. I hope these topics are helpful to you as you prepare to roll out your failover clustering environment. And I look forward to sharing more with you about this in another lesson.